Hi, welcome back to Moose Chemistry. This is Redox reaction, oxidation, and reduction in a basic solution, problem number 5. So let's look at our equation. O2 plus Sb yields H2O2 plus SbO2 negative. Well, the first thing we want to do is we want to write two half reactions. So let's go ahead and do that. So we're going to do Sb, right? It's going to go to SbO2 negative. Okay, and the second half reaction is going to be O2 yields H2O2. All right, so when we look at this reaction, remember that when elements are by themselves, they usually carry a zero charge. Put a zero charge above those. Notice that we have a negative number here. So if oxygen is -2 because it's in group 16, this will make this -4. What plus 4, -4, will equal -1? Well, Sb must be +3. Okay, so look at this one here. Here we have two hydrogens, right? So that's +1. So it'll give me a +2 overall charge. So oxygen, which is normally -2, but in this case would have to be -1. So this would give us 2 times -1, which would be -2. All right, so now that we've established that, we know that our oxygen is a -2 on the right side, and on the left side it's a 0. So let's look at our Leo the line goes GER. Lose electrons oxidize, gain electrons reduce. So Sb is going from a 0 to a +3, right? So that means it's losing electrons. Lose electrons. Oxidize, and it lost 3 electrons. Oxygen on this hand goes from 0 to -1. So we're going to gain electrons when it does that, right? Now, normally you would put 1 electron, like gain electrons, reduce, and you were thinking about tempted to put a -1 there, but you have to also consider there's a 2 there, right? So it's not just -1, but it's actually going to be -2. So that's going to give us 2 electrons. So now we understand that. So now what we want to do is we want to take our half reactions and we're going to go ahead and balance them. First of all, we're going to look at balance the non-oxygens and hydrogens first. So we look at the Sb's. The Sb's are already balanced. We don't need to do any of that. So the next thing we're going to do is we're going to want to balance our oxygens. So what I'm going to do is I'm going to clean this up a bit for right now, because it's really going to be difficult to see if I don't do that. Okay, so let's go ahead and clean all this up here. And let's make this good here. All right, here we go. And we're going to make everything look clean now. So now we're going to balance our oxygens next. All right, so now the right side of Sb to SbO2 has 2 oxygens, right? So to balance the oxygens, we have to add waters. So we're going to have to add 2 H2O to that side. Now, on the other one, we look at O2 to H2O2, and we notice that our oxygens, well, they're both 2. See, there's a 2 here, and there's a 2 there, so we don't have to worry about that. So let's clean this up a little bit here quickly. So that's taken care of. We're going to get rid of that O there, just to make it look cleaner. All right, now, the next thing we're going to do is we're going to balance our hydrogens. Now, over here we have 4 hydrogens, 2 times 2. So that means we're going to have 4 hydrogens here. On this side, we have 2 hydrogens. So we're going to need to rewrite this left side here. So let me go ahead and clean that up a bit. So we're going to do this. Watch what I do. I'm going to go O2 plus 2 hydrogens. Okay, so now that that's done, let's look at our next step. So we want to solve this in a basic solution. To do that, we're going to now have to add an OH to each side with the number of H's that it has. All right, so what does that mean? Well, we have 4 H's here, right? So that means we're going to need at least 4 OH here. Okay, and then on the other side of this equation here, see we've got now when we look at this a little bit closer, we also notice that we have 4 H's there, right? So let's go ahead and clean this up a bit and let's fix a couple things here, okay? So we're going to need to have 4 OHs on this side. So put a plus sign there and put 4 OH negative there. All right, now let's look at the other half reaction that we've got going on. We have 2 H's here, so we're going to have to put 2 OHs here. And on this side of the equation, we have 2 H's there, so we're going to have 2 OHs there. All right, so now we'll clean this up a bit again. So now what we're going to do is we're going to combine our OHs together. And so what we're going to get is we're going to get, let's see here, we're going to get, of course, top equation is going to be SB plus 2H2O plus 4OH negative. See that? That's this side right here. This side right here is going to look like this. Yields SbO2 plus 4H2O. So what I did was I combined these two here to give me that. Pretty darn snarly, huh? Let's look at the second half reaction. So we're going to make the second half reaction O2 plus 2H2O. How do we get that? We took these two right here to give us this 2H2O there. So let me do a little bit of cleaning up here before it gets really messy looking. And I'm going to go ahead and take off this part of it here, because that's going to get really messy. I'm going to go ahead and clean this up too. So far, so good. We still have that second side of that equation to do, and I'm going to take care of it right now. So let me go back to draw here, and this is going to yield H2O2 plus 2OH. So again, I'm going to clean all this up again because we need the space. So what I'm going to do is I'm going to rewrite these two equations that you now see, and then we'll work from there. So we have, of course, let's also get rid of that Leo there. Yeah. So let me rewrite everything. We have SB plus 2H2O plus 4OH negative yields SbO2 plus 4H2O. And then the second equation, of course, is going to be O2 plus 2H2O yields H2O2 plus 2OH negative. And now I'm going to clean everything else up so they give me more space. Because these problems take up an immense amount of paper. It's pretty impressive how they figured this out. Alright, so now, what we want to do next is we're going to now add the electrons to each side. So, let's see here. To the more positive side, I think it is, yes. So this 4, it's going to have 3 electrons. Remember earlier, we had 3 electrons there. And on this side, we're going to add 2 electrons there. But notice that this is a 2, and this is a 3. So what's common between 2 and 3? 6. So what does that mean? That means this. Let me go ahead and give some space here again. We are going to multiply the top equation, everything by 2. And the bottom equation, we're going to multiply everything by 3. And that'll give us our common units. So this will give us 2Sb plus 4H2O plus 8OH negative yields 2SbO2 plus 8H2O plus 6 electrons. On the bottom, we have 3 oxygens. I tell you what we're going to do. Let's make this a little bit better here. Let's erase that there. And we're going to do this a little bit easier. So this 3 is going to multiply that 2. So that's going to give me 6 electrons here plus 3O2 plus 6H2O yields 3H2O2 plus 6OH negative. All right, so now what we're going to do is this. We're going to change our pen color, and we're going to cancel out the things that we can cancel out. All right, so let's do that. So now when we look at this, we want to cancel out our electrons. We have 6 electrons on the right side. We have 6 electrons on the left side, so they're gone. All right, now notice that we have 4 and 6. That makes 10 waters. So what we're going to do is we have 8 waters here. So we cancel this one, and that's going to leave us 2 waters left over. See that? And now, of course, we have 8 OHs on this side. And, of course, we're going to have a total of 6 OHs on this side. So 6 OHs are going to cancel here and drop that down to 2 OHs there. So now, all we have to do is put everything back together. And here comes the fun part. So what this is going to do, this is going to give us this final equation. So let's go ahead and change the color of the pen one more time. All right, so what we're going to do is this. We got, start with this. We have 2Sb plus 3O2 plus 2H2O yields, not yet, hang on. Can't forget that OH right there. Plus 2OH there. Now that takes care of that. Now we can do the yield sign. Yields 2SbO plus 3H2O, O2, of course, through 3H2O2. And our waters. Let's see here. We have 10, 2, H2. That's good there. And that's it. So I'm going to rewrite the whole equation to make it look better down here. 2Sb plus 3O2 plus 2H2O plus 2OH negative yields 2SbO2 plus 3H2O2. Pretty amazing, and that's our correct answer right there. If you like this video, give us a like and consider subscribing so we can grow this channel. You guys be snarly. I will see you back here at Moosine Chemistry!